So this is the northwest corner rule. This method is called because the allocation from source to destination is always done to cell which is at northwest corner of the transportation matrix. We have 4 steps in this rule. First step is to consider the cell which is at northwest corner or the left uppermost corner cell given in the transportation table. Next, we allocate the maximum feasible quantity to the cell. In other words, it is to compare the demand and supply. I will explain it while solving the problem. Step 2 is to remove the row or column where demand or supply has become 0 or where the allocation is made which is equivalent to either A or B. The row or column containing A or B is struck from further iteration. Also, if A1 is allocated, subtract AI from Bj, or if Bj is allocated, subtract Bj from AI before continuing. Next, consider the transportation matrix minus the row or column, deleted again. Again, choose the northwest corner cell and allocate the minimum between demand and supply for that cell. Step 4 is to delete that row from further consideration and continue the iteration until all the demands are satisfied. To understand the steps given here, we will solve a problem. Find the initial feasible solution to transportation problem by northwest corner rule. This is the table given. Here this is demand and this is supply. The problem is balanced when we add this values and these values, both values should be equal. When we have added here, it has become 150. It means the problem is balanced. So coming to first step, what we have to do is we have to find the northwest corner cell, which means the first row, first cell of the first row and first cell of the first column, which is 5. This is the northwest corner cell in this table. Then find the minimum demand or supply. In this 65 and this 70, minimum is 65. So 65 is allocated here. 60 this becomes 65, like 65 is allocated here. Then we subtract this we subtract this 65 here, like we subtract minus 65, which becomes 5. So now this becomes 5. So see, it is the first step to select the northwest corner cell, which is nothing but cell corresponding to first row, first column, compare the demand and supply and allocate the lower. After we allocate here, we delete the entire column. So now the table becomes like this. Again, select the northwest cell, which is the element of first row and first column. This is the northwest cell. Again, select which is the demand between demand and supply, which is minimum. So here minimum is this. So allocate 5 here and subtract 5 to this. When we subtract 5 to this, it becomes 37. After we allocate, we have allocated this minimum to here. So we have to delete the entire row. If it was this, we would have deleted the entire column, but it is this, so we have deleted entire row. Now continue the iteration. This is the table now. Select the northwest cell, which is first element of the first row and first element of first column, which is this. This is the northwest cell. In demand and supply, this is the minimum. So allocate 30 here, and subtract 30 here. This gives 7. Now we delete the entire row. Because this is allocated, we delete the entire row. Coming here, now this has become our table. Again, choose the northwest cell. This is the minimum in demand and supply. So allocate 7 here and subtract 7 to here, which becomes 43. Then delete the entire column. This becomes our new table where both are 43. So any one can be allocated, and that's it. Write the final allocation table as given in the question and write what and all we have allocated in for each element. Then calculate the total cost, which gives 5 into 65 plus 7 into 5 plus 4 into 30 plus 7 into 7 plus 7 into 43. This gives 180. So this is the total cost. We got this like this: 5 into 65, 7 into 5. Same like that, calculate the total cost.